Greetings, math fans. Alright, so this is the review sheet for our Sequences in Series chapter, part 1. And again, it's a great study guide for the test. I would definitely look over all the other worksheets, okay, because there's a lot of different types of problems I can ask, and you need to know everything for the test. Alright, so let's get started. This is our key. Oh yeah. Alright, so find and everything here, it says you show everything with a formula. Of course, you guys know that. If you actually spend time counting, you'll never get done, because the test is certainly not going to have, oh yeah, find the sum of the first 5 terms. It's going to say find the sum of the first 500 terms, and you'll get one problem done for the test, and you'll be done. Okay? Alright, so anyway, find the 61st term of negative 1, or 1, negative 5, negative 11. Always have to determine is it geometric or arithmetic. Of course, you see this one is arithmetic. D comes out to be negative 6, so it's just a sub 61 is a sub 1 plus d, or minus 6 times 61 minus 1. So a sub 61 is negative 359. Okay, pretty easy. Number 2, arithmetic sequence. I give you, again, two kind of random terms in there, a sub 17, a sub 29. So we're going to shrink that down and bring this one down to a sub 1. So of course I'm going to subtract 16 right from that subscript, and so I get a sub 1 is negative 63, and subtract 16 from that as well, so I get a sub 13 equals negative 123. Easy as ABC, something like that. Alright, and then of course I'm finding a sub 55, so I'm really finding a sub 39. So it's just kind of like a new problem, but much easier, because then the first thing I'm going to do is I'm going to find D with a sub 1 and a sub 13. So I have negative 123 equals a sub 1, negative 63 plus D times, and then of course I'm using 13 now, right? 13 minus 1. So I wind up getting 12D, move this negative 63 over, equals negative 60, so D is equal to negative 5. Okay, and now I use that with this guy here, and with the or with my a sub 1, my arrow should be pointing over to here, okay, and that a sub 1, all right, and so I get a sub 39 equals a sub 1, which is negative 63 minus 5 times, and then 39 minus 1. So a sub 39 comes out to be negative 253, and of course a sub 39 is really a sub 55. Okay. Alright, number 3, find the sum of the first 35 terms of the sequence. Well, again, you can see that it's arithmetic, and you can see that D is equal to 4. Alright, and of course I need to find the 35th term, because our nice little friendly sum formula needs the first term and the last term, and so I need my last term. So D is 4, so I basically have a sub 35 equals a sub 1 plus D times 35 minus 1. So a sub 35 is equal to 124, and then I can use my sum formula. S sub 35 is the sum of the average of the extremes, so it's negative 12 plus 124 over 2 times n number of terms, which is 35, so S sub 35 is equal to 1960. That was a good year. Alright, number 4, given the sum, find the sum and that last term, find the first term and D. Okay, so we got to just use our sum formula. Negative 7208 equals a sub 1 plus, in this case here, of course, it's minus 188 over 2, the average of those, times the number of terms, which we know is 53 because of the subscript. And we just have to solve, however you want to solve. I'm going to multiply that by 2 and then divide by 53. So I wind up getting a sub 1 minus 188 is equal to negative 272. So a sub 1, add 188 to both sides, is negative 84. So that's the first part. And then I want to find D. That's pretty easy now, because I have a sub 53 and I have a sub 1. So I just plug it in and find the value of D. So I get negative 188 equals a sub 1, negative 84, plus D times 53 minus 1. So I get 52d is equal to negative 104. So d comes out to be negative 2. Okay, not bad. Okay, number 5. So given the sequence, and I give you s sub n, find the number of terms. So if you guys remember, that's going to be a factoring problem. Okay, so we're going to use our nice little friendly polysymult. So let's start out here. We got negative 4633 equals a sub 1, which is 27, plus a sub n over 2, the average of the extremes, times n. Well, again, we have two variables, so we have to kind of figure that out. What we need to do is come up with an a sub n general formula, no solution required. And we get a sub n is a sub 1, which is 27, plus d, which we see is negative 7, so it's minus 7 times n minus 1. Okay, and we simplified that, so it's going to be negative 7n, and it's going to be 27 plus 7 plus 34. So that a sub n then goes into that spot right there. And so we wind up getting negative 4633 equals 27 minus 7n plus 34 over 2 times n. Now we have one variable, and then we got to simplify this a little bit. So we're going to multiply both sides by 2. We get negative 9266, and simplify that inside there. So we get 61 minus 7n times n. So negative 9266 equals 61n minus 7n squared. And most of the time you're going to try to keep that that negative 7n. You want to have that positive, but it doesn't matter if you're going to use polysymult, right? So it doesn't really matter. So we can do negative 7n squared plus 61n plus 9266 equals 0. Okay, and it looks good. And then we use our polysymult. And again, if you're a little rusty with that, you don't remember that, if you go to part of my website, I have under ACT review, you can look at how to use polysymult in your graphing calculator. Okay. And anyway, you get two answers. You get n is negative 32.3 and n is 41. Of course, n is supposed to be a natural number, so no decimals and no negative numbers. It's got to be 1 or higher as an integer. So n is 41. Okay, good problem. All right, number 6, find the next 3 terms. So this is a recursive formula. It's just saying negative, so we're doing a sub 2, is the previous term, so negative 3 times the previous term, which is 14, plus 2, which is negative 40. And then a sub 3 is negative 3 times the previous term, which is negative 40, plus 2, which is 122. And then a sub 4, which is negative 3 times the previous term, which is 122, plus 2 gives us negative 364. Okay. The next one is based off of the 2 previous terms. So I'm looking for a sub 3, which is negative 2 times the previous term, which is 7, right? That's the one right before it, which is a sub 2, plus 5 times 2 ago, which is negative 12. And that gives us negative 74. So a sub 4 is negative 2 times the previous term, which is negative 74, plus 5 times 2 ago, which is a sub 2, which is 7. And that gives us 183. And a sub 5, which is negative 2 times the previous term, which is 183, plus 5 times 2 previous ago, which is negative 74, which gives us negative 736. Okay? So now we're creating a recursive and a general term formula. So let's do a recursive first. Of course, you got to remember, math fans. Well, let's look at the problem first, right? It's negative 192, negative 48 to 12 to negative 3, and you guys should recognize just by dividing it out, you're going to see that r is negative 1/4. Okay, that's pretty important. Got to know if it's arithmetic or geometric. And so basically, I'm multiplying it by negative 1/4 to get to the next term. but don't forget you got to define the first or second or whatever variables for recursive. So a sub 1 is 192. Don't lose points on that. Okay, and then a sub n is the previous term times negative 1/4. So negative 1/4 times a sub n minus 1. Very, very easy. Okay, and then a sub n is actually easier because I have my a sub 1 is 192, and I already have r, so it's a sub n is equal to a sub 1, 192, times r to the n minus 1. There we go. That's it. Okay. Okay, number 9. This one's creating a recursive formula for a little more complicated one. Not a big deal, but basically you see, I look at it and I go, okay, there's nothing I can multiply by 2 to give me 6, and then 6 to give me 4. So I start looking at multiple terms, and sure enough, I can see that 6 minus 2 is 4, right? And then 4 minus 6 is negative 2, and negative 2 minus 4 is negative 6, and negative 6 minus a negative 2. So I'm basically using the first two terms. So I would write a sub 1 because you got to find those first two terms that you're using. A sub 1 is 2, a sub 2 is 6. So then I would say a sub n. Well, what am I doing? I'm taking the term right before it, so a sub n minus 1, and I'm subtracting the 1, 2 before it, minus a sub n minus 2. And if you're not sure, just check it. You know, let's look at the, let's see, 1, 2, 3, 4. Let's look at the fifth term. Well, a sub 5, which is supposed to be negative 6, is the one right before it, which is negative 2, minus the one before that, negative 6. Okay, that's good. I'm done. So I need this, and I need that. That was just a check. Okay? All right, number 10. Again, you're looking at the sequence. Got to determine is it arithmetic or geometric, and of course, if you divide, you can see that r comes out to be negative 1/4. And so then I have a sub 9. It's pretty easy. It's just a sub 1 times r to the n minus 1, so to the 9 minus 1. And so a sub 9 comes out to be 1 over 8192. So make sure you use your fraction button. Okay? Okay, so the next one, number 11, math fans, is I give you guys some term in the middle, negative 48, and they give you r. And obviously what you're going to do is you're going to find the general term first, so then you can plug in a 14 later. So I need to find a sub 1. That's really my key here. So I have a sub n, which is negative 48, equals a sub 1 times r to the n minus 1, so to the 5 minus 1. Okay? And I solve for a sub 1 here, so I get basically negative 48 equals, that's going to give me 16 a sub 1, so a sub 1 is negative 3. And then I can come up with my general term really easily. A sub n equals a sub 1, negative 3 times r, which is negative 2 to the n minus 1. Okay, it's your general term. And then I plug in a 14. So a sub 14 equals negative 3 times negative 2 to the 14 minus 1. So a sub 14 comes out to be 24,576. Okay, number 12. Again, you're given two terms in the middle now. Now I'm asking you to find a sub 1 and r. All right. The first thing I need to do is I need to find r. So what I'm going to do is I'm going to shrink this down to a sub 1. I don't even write that. Negative 16 over 9. That's fine. And then I'm going to shrink that. Of course, I subtracted 3. So subtract 3 from that subscript. So a sub 4 is 128 over 243. Okay? And I just find r. No big deal. So it's 128 over 243 equals a sub 1, negative 16 over 9 times r to the n minus 1. Well, it's to the 4 minus 1. So it's r cubed. And then, of course, I need to solve for r. So I'm going to multiply by negative 9 over 16. Okay, and I get r cubed is equal to negative 8 over 27. So r is equal to, it's just negative, it's not plus or minus, right? So it's negative 2 over 3. So there's r. And then, of course, I plug it in. I can use either one of these formulas, but you got to use the original one. So I'm going to use a sub 4, and I got to find a sub 1. So I get negative 16 over 9 equals a sub 1 times r, which is negative 2/3, to the n minus 1. So to the 4 minus 1, because I'm using, again, that 4 right there, a sub 4, right? And I get negative 16 over 9 equals a sub 1 times negative 8 over 27. And then I multiply both sides by negative 27 over 8. And I get a sub 1 is 6. Okay, 13. I give you guys the first term, and I give you the general term, and you have to basically find n. So if you guys, I don't know if you remember this one, but you're going to have to use logs for this one because you're looking for the exponent. So we have a sub n, which is negative 1 over 1536 equals a sub 1, negative 2/3, times r to the n minus 1. Okay, so the first thing, please don't multiply negative 2/3 times 1/2. You're going to multiply everything by 3/2, negative 3/2. And you wind up getting 1/2 to the n minus 1 is equal to 1 over 1024. And then you take the log of both sides. And that n minus 1 then comes in front. And then I divide both sides by log of 1/2. So I get n minus 1 equals 10. Comes out to be a nice number. It's supposed to be a natural number, because how can you have the 1.6 term, right? It's going to be a nice number, 1 or greater integer, right? So add 1 and n comes out to be 11. So given the sequence, define the sequence by the nth term, the general formula. No solution required, of course. And you pretty much can see it's certainly not arithmetic. So if I divide it out, I wind up getting r equals 5/12, right? And so really pretty easy now. Now it's just a sub n equals the first term, a sub 1 times r to the n minus 1. That's it. That was easy schmeezy. Okay, keep going here. 15, it says find the sum of the first 6 terms. Okay, of course we're going to find out that this is, again, geometric, so r is 5/2. And please do not tell me, give me an answer like it is going to diverge. Okay, this doesn't diverge. If I asked you to find the sum, and I didn't say the 6 terms, I just said find the sum, then it would diverge because r is greater than 1 or greater than equal to 1 or less than or equal to negative 1, right? It's one of those two. But I'm not asking you for that. I'm asking you for the first 6 terms, the sum of the first 6 terms. So it's just s sub 6 is equal to a sub 1, so 13/5. There's a lot of parentheses in this one. Minus 13/5 times r to the nth power. Please don't do n minus 1 to the nth power over 1 minus r. Okay, so again, lots of parentheses around those fractions, around the top, or just hit enter on the top, and then parentheses definitely on the bottom. And your answer in fraction form comes out to be 67,431 over 160. Okay? Looks a little complicated, but it's actually not that bad. So this one's expand and evaluate. So you have to expand it, and you just need to write out the terms by plugging a 4, 5, 6, and 7 in there. So I'm basically, if I do that, I get 4 squared minus 3 times 4 plus 5 squared minus 3 times 5 plus 6 squared, minus 3 times 6 plus 7 squared minus 3 times 7. Okay, it's really pretty easy, right? And I multiply all that out, so that's expanded, multiply it all out, and I get 60. That's evaluated. Okay, this next one, if you had to do it that way for this one, you'd cry because you had to put in from 4 to 33. But you just recognize that this is arithmetic because of that negative 2. So if it's arithmetic, remember I need my first term, I need my last term, and I need number of terms. So first term is you plug a 4 into there, so negative 2 times 4 plus 6 is negative 2. And then my last term is plugging in the 33 into there, so negative 2 times 33 plus 6 gives me negative 60. And number of terms, remember, is 33 minus 4 plus 1. Got to always add that 1 in there. So that gives us 30 terms. And then it's easy. S sub 30 equals the first, negative 2, minus 60, so it's plus the last term, over 2, times the number of terms. So our answer for S sub 30 is negative 930. Okay. Number 18. So this is, you guys should recognize that this is a geometric, and of course R is equal to negative 3. Now you don't need the last term, which is kind of nice. We need the number of terms. So let's get that. And that's going to be 15 minus 4 plus 1. So that gives us 12 terms. Okay? And we need a sub 1. We need our first term. Of course, you plug a 4 into there. So negative 2 times negative 3 to the 4th power gives us negative 162. So now we have S sub 12 equals A sub 1, so negative 162 minus, I'll put that in parentheses, negative 162. You got double negative, so just be careful. And then it's negative 3 to the 12th power. Again, that needs to be in parentheses, the negative 3. Otherwise, it'll just be a negative number. It's supposed to be positive. And then over 1 minus negative 3. Again, that being in parentheses, lots of parentheses. So S sub 12 is equal to 21,523,320, which is pretty close to the current balance of my checking account right now. That's kind of cool. That's amazing. Okay, just kidding. Number 19, you invest $2,000. So guys, remember, when you're investing money, anything that has to do with money, you're going to be using your nice little friendly formula, A sub n equals A sub 1 r to the n, not to the n minus 1, okay? Because year 0, we're not talking, year 1 is not when I'm investing the money. It's truly year 0. Year 1 is I've already got 1 year under my belt. So that's why you got to use to the n power, okay? So pretty easy. It's A sub 40 is equal to 2,000. It's A sub 1 times 2.7. So it's 1 plus 0.027. That's 2.7%. Be careful about that. And that's to the 40th power. Okay, so it's 1.027. And we get A sub 40 comes out to be, and again, round to the nearest 2 decimal places, which sense, and it makes sense too, 5805.61. Okay, not bad. Okay, number 20, you purchase a gold iPad. Oh, fancy, for $50,000, and it depreciates. I hope you guys took the insurance out on that baby. And it depreciates 8% per year. What is the value of the iPad in 15 years? So again, this is a money problem, and it's depreciating, so your R value is going to be 1 minus 0.08 or 0.92. Very, very important. Please don't put 0.08 in there, because that's like saying, oh, it's worth only 8% of its value in 1 year, and you're going to cry because it's going to be worth like nothing in 15 years. All right, anyway, we have A sub 15 is A sub 1, which is 50,000 times R 0.92 to the 15th power. So A sub 15 is equal to, rounding to the nearest 2 decimals, of course, $14,314.87. Okay, not bad. By investing $150 in NetBank, which is a bank from a long time ago, an internet, for one of the first internet banks, out of business now, you triple your money. So if you triple your money, R is 3. Okay, if you double your money, R is 2. You quadruple your money, R is 4. So it says how many years until you have $150,000. So A sub n is 150,000, and A sub 1 is 150 bucks, and my R again is 3 to the nth power. And of course, we're going to divide first by 150 So you get 3 to the n is 1,000. And then I take the log of both sides. Got to use logs when you're looking for that exponent. So the n comes to the front. And so we have n log of 3 equals log of 1,000. And I divide by log of 3. And n comes out to be a nice, well, actually it's not a nice number, 6.29. So it's, if you put 6 years, it's not true because it doesn't triple your money until the 7th year. Then it's triple your money. It's not, 6 years is not enough. It's going to be a little bit less. So you need to round up, and you get 7 years. Okay, 22, find the sum of those terms. Of course, you're going to check this out, and you're going to see it's geometric, which r gives you -1/8. And what do you recognize here, math fans? Dot, dot, dot. And I don't say find the sum of the first so many numbers, right? So this is an infinite geometric series, and r is between -1 and 1. If it was not, then you would say it diverges. So we're doing s sub infinity equals a sub 1, which is 12 over 1 minus -1/8. So we get 32 over 3. Okay? Not bad. Okay, so another one of these, right? It's infinite geometric, so you're going to divide it out, and you're going to get r is equal to 5 halves. Actually, r is equal to -5/2, right? Boo! Greater, remember that the absolute value of r has to be, in order for this to work, has to be less than 1, which means it has to be between -1 and 1. It's not, so this one diverges. Okay, sounds good. Okay, let's move on to the next one here. Okay, so this is an evaluate a geometric series. Just because you have an infinity here, you got to know that, right? And so what we need is, since it's infinite, we need a sub 1 and we need r. Well, r is easy. It's -1/2. That's right there. And then a sub 1, well, you plug in the 4, right? So it's 2 times -1/2 to the 4th power. So a sub 1 comes out to be 1/8. And then we stick it in a nice little friendly formula. S sub infinity is equal to a sub 1, 1/8, divided by 1 minus a -1/2. Make sure you use, again, parentheses on the bottom there. And s sub infinity is 1/12. Okay, not bad. Okay, we're getting there. Okay, so number 25 says find the 4 arithmetic means between -17 and 53. And if you guys remember, you're going to write -17 and you're going to put 4 blanks here, and you're going to put 53. And so this is your a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So then I'm going to use these two values right here to figure out the value of d, because I know it is arithmetic. All right, so I'm going to do 53, a sub n equals a sub 1, -17, plus d, which I'm trying to find, times n minus 1, and n is, of course, 6, so 6 minus 1. So I get 5d is equal to 70, so d is equal to 14. And then basically what I'm going to do is I'm going to say that it's -17, and then, of course, I'm going to add 14 to that. And that gives me -3, so that's one of those. And then I'm going to add 14 again, and I'm going to get 11. I'm going to add 14 to that. I'm going to get 25. And I'm going to add 14 to that. And I'm going to get 39. And if I add 14 to that, I better get 53. Okay? And so then my answers are these guys right here. Those are my 4 arithmetic means. All right? 26, find 3 geometric means. So now what we have to do is we got to find the value of r. So we're going to do kind of the same thing. 27 halves, and then 3 blanks, and then 128 over 3. So again, we're going to label this a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. And so then when I set this up, it's going to be a sub n, which is 128 over 3, equals a sub 1, 27 halves, times r to the n minus 1. Okay, and of course multiply both sides by 2 over 27, and I get, oh, and of course n, I didn't put n here, sorry, n is 5, right? 5 minus 1. So I wind up getting r to the 4th is equal to 256 over 81. Then I take the 4th root of that. Please do not forget, when it's an even root, it's plus or minus. So r equals plus or minus 4/3. Okay, so now what we're going to do is we're going to have one answer for positive 4/3, and that's going to, so let's put all our numbers here, 27 halves. I'm just going to put another set of blanks here, 1, 2, 3, 128/3, and then r equals negative 4/3, 27 halves, 1, 2, 3, 128/3. Okay, so again, you're just multiplying 27 halves by positive 4/3. If you do that, you get 18. And multiply again, you get 24. And multiply that, you get 32. Then if I do that one more time, I would get 128/3, just to check it. And the only difference between that and this next one, which is negative, is just this: when I multiply it by first term by negative 4/3, I get negative 18 times a negative 4/3, which is positive 24, times a negative 4/3, which is negative 32. Okay? So those are two sets of answers that you guys would have for those geometric means. Okay? All right, and last problem. It says find the general term, no solution required, for the following sequence. Leave no parentheses in your answer. Okay, that's really important. You got to simplify it. Well, first of all, if you look at this problem, is definitely arithmetic because however you want to do it, but you can say d is equal to negative 92 minus a negative 96, right? It's like saying plus, and so you can even see we're adding 4 here. So it's going to be a sub n equals a sub 1, negative 96 plus 4 times n minus 1. If you leave it like this on your quiz or test, you're going to lose a point because it's not simplified. You guys need to simplify it so it's negative 96 plus 4n minus 4. So a sub n, I like putting it in descending order, so 4n minus 100. Okay, and you can even check it by plugging in a couple of values. If I want to plug in, let's say for the first term, well, that's 4 times 1 is 4 minus 100, negative 96. Second term, 4 times 2 is 8. 8 minus 100, negative 92. It's a good way to check it. But this is my general term, a sub n. Okay? Anyway, that's it, math fans. That's the whole review sheet. It's got a lot of stuff on it. I would definitely go over the other worksheets and make sure you guys are good to go with every type of problem I could possibly give you, because you're going to see pretty much every type of problem on that test. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.